Welcome back, everyone. We're continuing on in Chapter 2, talking about our quadratic functions and some characteristics of those quadratic functions. Remember, our parent quadratic function is f of x is equal to x squared. So we're going to talk about a part of our parabolas that will help us draw our parabolas in the future, and it's called an axis of symmetry. So I'd like you to start with just making a t-table. Remember, our parent function t-tables go from -2 to 2. And just for showing more about what our axis of symmetry does, we're going to go from -3 to 3 this time. And remember, we get our y values by plugging in our -3 to our parent function and squaring it. So -3 squared is 9. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So we're trying to figure out, do we notice a pattern on our y values? And I'm thinking, well, I know that 0, 0 is our vertex for our parent functions. And so if I look on the left side of my vertex, my numbers are 1, 4, 9. Then if I look at the right side of my vertex, my y values are also 1, 4, and 9. So we're noticing that our y values repeat on both sides of 0, 0. And the reason for this is our axis of symmetry. So parabolic symmetry is the fact that we can draw a line straight through our vertex. And on that line, just like in geometry when we had lines of symmetry in our squares or our rectangles or our triangles, that meant that we could fold that figure at that line and have it fit exactly back onto itself. When we draw this line in our graph, we're calling it the axis of symmetry. And I usually shorthand that as AOS. It has the equation of x is equal to h. And it also has to be exactly the same as the x value of the vertex. So I'm going to remind you again of vertex form, which was x minus h squared plus k, where our hk is our vertex. So whatever this value is, not only gives us our vertex, but it also gives us our axis of symmetry. Let's try a couple. Let's start with number 1 and discuss all of the transformations that are happening first. So this negative is an x-axis reflection. This 2 is a vertical stretch by 3. The plus 3 in the parentheses, really, because x's are liars, right, means left 3. And then the plus 4 is an up 4. We also know, because this is vertex form, once I change this to the -3 that it really is, that -3, 4 is my vertex. That also tells me that my axis of symmetry is the line at x equals -3. So to graph this, always starting with our parent function coordinates from last section. And then a reminder that we do our transformations from left to right. So our first transformation is that x-axis reflection. And we said that that x-axis reflection changes the signs on our y values in our table. So negative, 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 negative. Remember, 0 can't be positive or negative, so we're not going to change that. The vertical stretch takes our y values and multiplies them by 2. Remember, our x values are not changing at all in these two tables that we're making. So for our y values, taking this table right here and multiplying those values by 2. Negative 4 times 2 is negative 8. Negative 1 times 2 is negative 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And negative 4 times 2 is negative 8. And again, that should make sense because we said on either side of our vertex, these values should be repeating. So I'm going to work on making a sketch of our graph. So starting with this blue set of ordered pairs, negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, 2, negative 8. Then I'm going to take those 5 points and go left 3 and up 4 with each one. So starting on the left, left 3 and up 4 brings me here at negative 5, negative 4. The second one, left 3 and up 4, puts me at negative 4, 2. Our 0, 0, left 3 and up 4, puts me at negative 3, 4. And then my other 2, and here is my parabola. Our axis of symmetry goes right through our origin at x equals negative 3. So make sure you draw that in and label it. And there's our graph. All right, number 2. This 0.5 is the same as 1/2. That's a vertical shrink by 1/2. And then inside our parentheses, remember x is our liar, so that's a right 4 and a down 2. We also know, because this is in vertex form, that our vertex is at 4, negative 2, and that our axis of symmetry is at x is equal to 4. So again, starting my t-table from our parent function, our shrink of 1/2 means we're multiplying our y values by 1/2 or taking half of them. X values do not change, so our x values stay the same. 4 times 1/2 is 2. 1 times 1/2 is 1/2 or 0.5. 0 times 1/2 is 0. 0.5 and 2. I'm going to sketch this graph. So right now we have negative 2, 2, negative 1, 1/2, 0, 0, 1, 1/2, and 2, 2. Now we're going to assign each one of those right 4 down 2. So right 4 down 2 brings me here. Right 4 down 2 is here. Our 0, 0, right 4 down 2 at 4, negative 2, here and here. So here is my lovely new parabola. Draw in our axis of symmetry at x is equal to 4. This is where we're going to stop today. Make sure that you have your beautiful graphs and everything with you. We'll see you tomorrow.